All right, today's lesson is going to be on 4.5 function operations. The domain will likely be all real numbers unless there is a variable in the denominator or a variable under a radical. Now, the reason for that is because you cannot have a negative underneath an even radical because then it becomes imaginary. The definition of a function, a rule or rules in which for every input X, there is exactly one output Y. Here we have our basic operations. Add, subtract, multiply, and divide. But usually you don't see a multiply with the X symbol, we see it with the dot. Example 1. We are going to perform the function operation and state the domain. We're going to let f of x equal x plus 4 and g of x is equal to 2x squared plus 7x minus 4. Always pay attention to the operation in the middle. Now, what you're basically going to do is you're going to substitute. So right here, f of x is going to equal to x plus 4 plus in the middle. And now I'm going to plug in g of x, and g of x is equal to all this good stuff. 2x squared plus 7x minus 4. Now here, because I'm adding, I don't need to worry about distributing. I'm going to go ahead and combine like terms starting with the highest power. The highest power here is going to be the x squared. So it's going to be a 2x squared. Next is going to be the x. So that's going to be a positive x and a positive 7x. There's a 1 here you just don't see. So 1 plus 7 is going to be 8x. And then I'm going to do my ones digit, positive 4 and negative 4, while those cancel out. I'm not done. I have to state the domain. Now, remember what we said up here about the domain? The domain will likely be all real numbers unless there is a variable in the denominator. I don't have a denominator. Or a variable under the radical. I don't have a radical. So right here, my domain is going to be all real numbers. You can also write it like this, negative infinity to positive infinity. That's as an interval. Or as an inequality, it's going to be negative infinity is less than or equal to x is less than or equal to infinity. On B, subtracting. Now make sure you're plugging the correct function in the correct spot. So this is a g of x. So the g of x goes first now. So the g of x is going to be the 2x squared plus 7x minus 4. Subtract. Now I'm going to plug in the f of x, and the f of x is the x plus 4. Now on this one, you need to distribute the negative symbol. So this is going to be a negative x, and this is a negative 4. If I catch a mistake, it's always on this spot. This first polynomial is going to stay the same. I didn't worry about distributing here because it was all positives anyways. But here, when you're distributing the negative, it's changing the signs on both terms in the parentheses. Now I'm going to combine like terms. Start off with the highest power. Nothing goes with the 2x squared. Next goes positive 7 minus 1, which is going to be a positive 6x. And then my ones digit, negative 4 minus 4 is a negative 8. Once again, I have no denominator and I don't have a radical. So my domain here is going to be all real numbers, or negative infinity to positive infinity, or negative infinity is less than x is less than infinity. We are now going to be multiplying. So f of x goes first. That's going to be the x plus 4. G of x goes next. So that's going to be a 2x squared plus 7x minus 4. I'm going to take step by step. I'm going to first distribute the x. X times 2x squared is going to be a 2x cubed. X times 7x is going to be positive 7x squared. X times negative 4 is a negative 4x. I'm done distributing the x. I now have to distribute the 4. 4 times 2x squared is going to be positive 8x squared. 4 times positive 7 is going to be a positive 28x. And then 4 times negative 4 is going to be a negative 16. I'm now going to combine like terms. Nothing goes with the 2x cubed. Next goes x squares. That's 7x squared and 8x squared, which is going to be a 15x squared. Next goes my x's, which is a negative 4x plus a 28x. That's going to be a positive 24x. And then my ones digit. I have no denominator and I have no radicals. So my domain here is going to be all real numbers. Negative infinity to positive infinity. Negative infinity is less than x is less than infinity. So I just did an add, a subtract, a multiply. I'm now going to do a divide. Now keep in mind, g of x. G of x was the 2x squared plus 7x minus 4. And the f of x is the x plus 4. On the top, this goes back to last chapter. I'm going to go ahead and I'm going to try to factor that. Two x squared, that can only be performed by a 2x and an x. Now, options for 4 are 1 and 4 or 2 and 2. Let's see if a positive, an x plus 4 works. I have a feeling that might work. So I mean that has to be a 1. And because that's a negative sign, this has to be a negative. So let's see. 2x times x is 2x squared. Negative 1 times 4 gives you the negative 4. And then right here, that's going to be a negative 1x and a positive 8x, which does give you the 7x. So I use that denominator to kind of guide me on my factoring. Well, x plus 4's cancel. So yes, your final answer will be a 2x minus 1. Now, when we're talking about your domain, I don't have a denominator here or a radical. However, right here, I did have a denominator because remember, this is considered a whole, which means it's out of the denominator. I mean, it's out of the domain. So right here, x plus 4 cannot equal 0. So x cannot equal a negative 4. So that is your restriction on your domain because that creates a whole. So the domain here is all real numbers except negative 4. If you write it in interval notation, it's going to be negative infinity to negative 4. And I'm putting parentheses because I don't want to include it. Union, and then pick back up at negative 4 and go to positive infinity. So on this side, I'm introducing the negative 4.0001. On here, it's negative 3.99999. So these are two ways you can write it. All right, just like in example 1, we are using different functions now. I want you to perform the operations and state the domain. We're going to let f equal x squared plus 3x minus 18, and g of x equals x minus 3. Go ahead and pause and try to solve these and make sure that your answer matches. All right, f of x goes first. That is an x squared plus 3x minus 18. The operation in the middle is a plus sign. And then g of x is going to be the x minus 3. Now I'm going to go ahead and because I'm adding, I'm just basically combining like terms. Nothing goes with the x squared. 3x plus x is a 4x. And then negative 18 minus 3 is a negative 21. And the domain here, because I have no radicals and I have no denominator, is going to be all real numbers. Part B, we are subtracting here. Plug in the g of x first. So the g of x is the x minus 3. Subtract. Now the f of x goes next, which is the x squared plus 3x minus 18. Before I combine like terms, I need to distribute that negative. I have to distribute that negative to all the terms behind it. So right here, the x minus 3 is still there, but now that's going to be a negative x squared, a negative 3x, and a positive 18. Now I'm going to combine like terms. And my domain here is going to be all real numbers. Multiplication now. Multiplication. So the f of x is going to be the x squared plus 3x minus 18. The g of x is going to be the x minus 3. That's going to be x squared times x is going to be x cubed. X squared times negative 3 is a negative 3x squared. I'm done distributing the x squared. 3x times x is going to be a 3x squared. 3x times negative 3 is a negative 9x. Negative 18 times x is negative 18x. And then right here, a negative times a negative is a positive, and 18 times 3 is going to be a positive 54. Nothing goes with the x cube. Now look, here I have x squares. Negative 3x squared plus 3x squared, those actually cancel out. And then here, negative 9x minus 18x is going to be a negative 27x. And then nothing goes with the 54. My domain here is going to be all real numbers. Here we are dividing. G of x is the numerator, so that's going to be the x minus 3. In the denominator, I have the x squared plus 3x minus 18. I'm going to go and I'm going to factor the denominator. Now I have an x squared, so I need an x and an x. Now 18, that's going to be a 1 and 18, 2 and 9, or 3 and 6. But I know it's going to be a 3 and a 6 because of that 3. And I have a feeling that it's going to be a minus 3 and a plus 6. Now let's see, negative 3x plus 6x does give me the positive 3x. Now before I continue, remember we talked about restrictions? Your restrictions, you now have two denominators. So right here, the x minus 3 cannot equal 0, so x cannot equal a positive 3. And the x plus 6 cannot equal 0, so x cannot equal a negative 6. So there's going to be your two restrictions on your domain. And here the x minus 3's cancel. Now, if you put x plus 6 as your solution, that is incorrect because the x plus 6 is a denominator. It's like saying 3 is equal to 1/3. No, it's not. The x plus 6 has to be in the denominator. And now my domain is going to be all real numbers except 3 and negative 6. Now, the last main concept here has to do with composition. Now, composition of functions is when a function within a function now the symbol of composition, it almost looks like a multiply sign, but it's not. It's actually a circle. It has an open circle. And it's written like this: f of g of x. And because the g is closest to the x, the f is going to be on the outside and the g of x is going to be on the inside. So this is the way it's read: f composed with g at x. So here basically you're going to plug g of x into the f of x because the g of x is on the inside. All right, so on example 3, we're given that f of x is equal to x squared and g of x is equal to 2x plus 1. Now, because the g is closest to the x, that's going to go on the inside. So the f is on the outside and the g of x is on the inside. You have to plug in the g of x first because that's the parentheses. So what does g of x equal? G of x equals 2x plus 1. So I'm going to plug in all of 2x plus 1 right there. So that's going to be 2x plus 1. And because I plugged it in, do not write g of x anymore. Because g of x, I substituted in 2x plus 1. Now I have an f on the outside. So basically now I'm going to plug in this 2x plus 1 into the function of f. So right here it says f of x equals x squared. So everywhere I see an x, I'm going to replace it with this 2x plus 1. So I'm going to put a 2x plus 1 right there. So then this is going to be a 2x plus 1 squared. And because I plugged in the x, do not write the f on the outside anymore. You're just plugging in and then plugging in again. 2x plus 1 squared means 2x plus 1 times 2x plus 1. 2x times 2x is 4x squared. 2x times 1 is going to be a 2x. 1 times 2x is 2x, and 1 times 1 is 1. Combining like terms, this is going to be a 4x squared plus 4x plus 1. And if I asked you for the domain, it would be all real numbers. Now, b is different because on b, since the f is closer to the x, that's going to go on the inside. So the g is on the outside and the f of x is on the inside. You first have to plug in the f of x because that's inside the parentheses. So what does f of x equal? It equals x squared. So I'm going to put an x squared right there. So that's g x squared. Once I plugged it in, it's gone. Now I'm going to go to the g equation, and everywhere I see an x, I'm going to plug in an x squared. So right here I see an x, so I'm going to put an x squared right here. So it's going to be a 2x squared plus 1. And because I plugged in, that g is gone. And then here, I'm done because those are not like terms. Now, you could do two things right here. I'm going to go and show you guys how I did it, and then I'll show you a different way. So right here, that's what I'm doing first because that's on the inside. So the f is on the outside. The g of 5 is on the inside. So now I have to plug in g of 5. So everywhere I see x, I'm going to plug in the number 5 there. So that's going to be 2 times 5 plus 1. 2 times 5 plus 1. And because I plugged the 5 in, the g's gone. Now 2 times 5 is 10 plus 1 is 11. Now I'm going to go to the f function, which says x squared, and I'm going to plug in the number 11. So when I plug in the 11, the f is gone. And then 11 squared is 121. Another way you could have done it is I already know what f of g of x was. Taking into account that you did this correctly, f of g of x was equal to 4x squared plus 4x plus 1. And this question is asking for f of g of 5. So everywhere you see an x, you're going to plug in a 5 there. So this is going to be 4 times 5 squared plus 4 times 5 plus 1. Order of operations says to do exponents first. 5 squared is going to be 25. Next, I'm going to multiply. 4 times 25 is 100. 4 times 5 is 20. And then I have this plus 1, and that equals 121. So you could solve it both ways. Last example. I want you to find out what f of g of x is and g of f of x and f of g of 1. Notice how I didn't put that in composition form, but it actually is. I just wrote it differently. When the f of x is going to be equal to 2x minus 5, and the g of x is equal to 8 minus x. You can go ahead and hit pause and solve this out and then see if your answer is correct. First, I'm going to do this one. So I have f of g of x. The g of x goes on the inside because that's the closest. So the f is on the outside. The g of x is on the inside. I had to plug the g of x first. So that's going to be the 8 minus x. So I'm going to put 8 minus x right there. So f is on the outside, 8 minus x is on the inside. And because I plugged it in, the g is gone. Now I'm going to go to the f equation, and everywhere I see the variable, I'm going to plug in 8 minus x. So I put an 8 minus x right there. So it's going to be 2 times 8 minus x, subtract 5. And because I plugged it in, the f is gone. Distribute, so 2 times 8 is 16, minus 2x minus 5. When I combine like terms, I'm going to put the variable first. And 16 minus 5 is positive 11. Now I'm going to find g of f of x. Because the f is closer, that's going to go on the inside. So g is on the outside. F of x is on the inside. Plug in the f of x first. So that's going to be 2x minus 5. So I'm going to put a 2x minus 5 there. And because I plugged it in, the f is gone. And then I can't forget the g on the outside. Now I'm going to go to the g. Everywhere I see the variable, I'm going to plug in 2x minus 5. Now be careful right here because it says 8 minus the variable. So it's going to be 8 minus, now plug in the x inside parentheses because you are subtracting all of the values. So right here, I'm going to distribute the negative. So this is going to be an 8 minus 2x plus a 5 because a negative makes that a positive. Because if you make a mistake, it's going to be right here. And then when I combine like terms, I'm left with negative 2x plus 13 because 8 plus 5 is 13. Now on this one, I have f of g of 1. I'm going to plug in g of 1 first. So g of 1, that's going to be 8 minus 1, which is going to be a 7. Now I'm going to go to the f equation, and everywhere I see the variable, I'm going to plug in the number 7. So that's 2 times 7 minus 5. So this is a 14 minus 5, which is a 9. And just know that right here, this is the same as f on the outside, f of g of 1. Because see how the g right there, that's g of 1, and the f is on the outside. So I could have also plugged it into here, taking into account that I didn't make any mistakes. And that concludes our notes.